Hello everyone. So for today we continue with chapter 4, which is a syntax and semantic analysis, which is actually a second phase of a compiler. So for chapter 4, there are quite lots of sections actually that we will cover in this chapter 4. So altogether they have 13. So this will be spread on several lecture videos. Okay, so the first part we will look into a grammar, language, and as well as the push-down machines. So for the first one here, we need to know that the syntax analysis actually is the second phase of a compiler. So the input for this phase actually is a streams of tokens, which is taken from the lexical analysis, which is the first phase of compiler. Okay, so the output actually is the streams of atoms or a syntax tree. So the output for syntax analysis is the form of atoms and syntax tree. So what is the purpose of syntax analysis? The purpose would be to detect and scan for any syntax error in the code. So when we given a code, then the compiler will be able to tell you whether the code contains a syntax error or not. For example here, this is a Java code. The first one, x equals to 2 plus 3 times 9. The syntax error there would be mismatch parenthesis, which is the bracket. Supposedly, before the number 2, there is another bracket there. Okay. It's the opening bracket for the bracket after number 9. The second one, if x greater than y, x equals to 2. This is also a parenthesis, which is also a bracket. Supposedly, x greater than y should be in a bracket. The third one, while x equals to 3, do F1. So this is invalid keywords do, because in the while statement, they don't have this kinds of syntax. Do after the while statements. Okay, so this is the examples of syntax error that commonly occur in our code, Java code. Okay. So before we know how to do a syntax analysis, okay, before we need to understand what is a syntax analysis, we need to know a formal language used behind it. Okay, so one of it is use a grammar. We also learned about a finite state machine before. So the next one here is a grammar. So what is a grammar? Grammar is a list of rules which can be used to produce or generate all the strings of a language. Okay, so, and which does not generate any string or which are not in the language also can. Okay, so the formal definition for grammar actually it consists of a finite set of character. It also have a finite set of symbols, also a finite list of rewriting rules. So what is a finite set of character? So it is called as an input alphabet or the input symbols or a terminal symbols. Okay. So it normally can be a digit 0, 1, or it can be an alphabet as well. Okay, this is a terminal, means that this is the string of the grammar, string of the language. Okay. Number 2 is the finite set of symbols. So distinct from the terminals, this is called non-terminal symbols. Okay, so exactly one of which is designated the starting non-terminal. So every grammar they need to have at least one starting non-terminal in its production rules, in their rules. Okay, so if no non-terminal is explicitly designated as the starting non-terminal, so it is assumed to be the non-terminal defined in the first rules. So first rule will be the non-terminal if it is not mentioned. Okay. The third one, a finite list of rewriting rules is also sometimes called production rules. Okay, so which define how string in the language may be generated. So this production rule will determine how are we going to derive a string for our language? Okay, so this is the rule that will determine. Each of these rewriting rules is of the form A goes to B. Okay, so where A and B are arbitrary string of terminals and non-terminals, and A is not null. So A must not be a null. Okay, at least one non-terminals on A. Okay, and A and B can be consist of a set of a non-terminal as well as a terminals. Okay, example of grammar G1. The grammar G1, which consists of 4 rules, the terminal symbol 0, 1 and the starting non-terminal S. So here, in this example, they give the terminal symbols as 0, 1. Means that the string for the language will be in the form of 0, 1. Okay? So the starting non-terminal, which is S. So S is the starting point for us to derive our string. Okay. So based on the grammar given here, the production rules, we have 4 production rules here. Number 1, 2, 3, and 4. Okay. All 4 of these production rules start with S. So means that which one that we should start with. So we can start with either one of these. You can start from 2, you can start from the third one, you can start from the fourth one, any. Okay, any of them, because all of them is S. Okay, as an example of derivations, you can derive your grammar. You can start with 3, means that S goes to 0, means that the first string that you encounter will be 0. 0 is one of the string in this language. Okay, or you can go for S goes to 1, then 1 is another string in this language. Okay, for this example of derivations, you use the first one. S goes to 0, S0, which is the first rules here. Then the S here, S ins here, they replace it with the first rules again, 0, S0. And then the S here, the second S here, they derive it and they replace it with the second rules. So is it any order to derive the non-terminal symbol? No, you can choose any of them as long as it is the same non-terminal. So in this case, terminal is 0 and 1. So the one that is not terminal is a non-terminal. So terminal is 0, 1 means that S is a non-terminal. So you need to derive your grammar until you get all of this is a terminal symbols. So 0, 0, 1, 0, 1, 0, 0, all is a terminal. So we say that 0, 0, 1, 0, 1, 0, 0 is a language inside grammar G1. Okay, this is only one of the string derived from this grammar. There's a lot more. Okay, other string will be 1, which is derived from the third production rules. The second is 0, 0, derived from the third rules. 1, derived from the fourth rules. And 0, 0, 0 is derived from the first and third. Okay, and the rest of it. So there's a lot more infinite. Yeah, how do you know it is infinite? Because this here you see S goes to 0 S1 means that it can call the S again and again and again. So it will be in repetitions. So these are all the string accepted by grammar G1. Okay. Let's look into another example, G2. The terminal symbol used here is A and B. So epsilon will represent the null string and is not a terminal symbol. Epsilon is not a terminal. Yeah. Okay. The production rules here, there are 4. S goes to A as B, S goes to epsilon, S go to A go to A, B go to B. So here the terminal is small letter A and small letter B. So the rest of it is non-terminal symbol. Okay, I repeat. The terminal symbol here is A and B, small letter. So the rest of it will be non-terminal, means that as capital A, capital B, epsilon is a non-terminal symbol. So how to do the derivations? You can start from S, goes to epsilon, then you get epsilon here. Okay. If you start from the first one, S goes to A S B, so you can replace the S here with A S B again, or you can start also. You also can start with derivation A here. In any order, doesn't matter. Yeah, you can start to derive S first. You can also start to derive B first. Also can in any order, but at the end you must get all terminal string. AABB. Yeah? So this AABB is one of the language inside G2. So other language accepted will be AB, AABB, AAABB. So this is also infinite because you see as here can goes to aspect. You will get an enumerated of a string for this language. So you can write it in the form of regular expression as well, such as you can write A to the power of n, B to the power of n. But this is actually not to the power of n, means that n would determine, n actually indicate number of occurrence, means that if n is 2, means that A occurs 2 times, means that A. So B, B. If n is 3, it means that A, B, B. Okay, so such that n must be greater or equals to 0. So when n is equals to 0, this is where you get epsilon. When n is equals to 1, that is where you get AB. When n is equals to 2, that is where you get AABB. Okay, this is the language accepted. Or the language also can be written in the form of sentences like this one. This language is a set of all strings of A's and B's which consists of 0, because of the epsilon, or more A's followed by exactly the same number of B. So that is another way to represent your language. Okay. Okay, now we want to see what is equivalence. Equivalence means if the two grammar G1 and G2, it is said to be equivalent if language inside G1 and language inside G2 is the same. It means that the string derivated from both of the grammar is the same. Then we call that both of the grammar is equivalent. Okay, but in this case, in the previous case, example we see G1 and G2, the language generated is not the same. Then we say that it is not equal. Now we want to look into a classes of grammar. This one is actually a Chomsky classifications of grammar. This one is to determine the types of grammar that we have from the productions rules. We want to know what is the types of grammar. So there are 4 of them. The outer layer here is the unrestricted, which we call also type 0. The second layer is context sensitive, which we call type 1. The third layer here is context free, which we call type 2. And the inner layer is type 3, right, linear. Sometimes we call this as a regular grammar, regular grammar, okay? So this is the types of grammar. There are 4 of them. So why is it they do it in the subset like this, like a circle and another circle in another circle? This would indicate that in order to be in type 3, the grammar have to fulfill the restriction in types 2. In order to be in a type 2, the grammar must fulfill the restriction in type 1. And if it is not type 3, not type 2, and not type 1, means that it is type 0. Okay. When you are asked to determine whether what is the types of grammar, you need to start with type 3 first. If it's not type 3, then you look into type 2. If it's not type 2, then look into type 1. So if it's not 3 of them, means that it is type 0, which is unrestricted. Okay, so here is some symbols and meanings in order to understand for the next examples. You need to know this. the first one, ABC, is a single non-terminal. A small letter is a single terminal. XYZ is single terminal or non-terminal. The small letter XYZ is a string of terminal. Alpha, beta, gamma is a string of terminal and non-terminal. So this is the symbol that we are going to use in the future examples. Okay, now is the explanation of each of the types of grammar. So the first one is unrestricted. Unrestricted means there is no restriction, there is no rules for these grammars. Okay, so the example is SAB goes to CS. Okay, this is example. S and B is the non-terminal, A and C is a terminal. Okay, now we want to see type 1. Okay, type 1, context sensitive. A context sensitive grammar is one in which each rule must be of the form. In this form, you look at here, is alpha A gamma goes to alpha beta gamma. So what does this mean? Okay, it says here where each of alpha, beta, gamma is any string of terminals and non-terminals. So it means that the alpha, beta, and gamma can be terminals, can be non-terminals, including epsilon. So alpha, beta, gamma can be epsilon as well, means the empty string. And A represents a single non-terminal. So the first thing you see here, you must have at least a non-terminal, single non-terminal, A on the left of the representations. Okay, I would say the one that before this arrow is on the left, the one that after this arrow is on the right. So every time I say left means that the one before arrow, and every time when I say right, it means the one after the arrow. Okay, so means that there must be at least one non-terminal at the left side. Okay, the left side. In this case, is represented with A. So alpha and gamma here, if you see here, in between, before A, before the non-terminal, and after the non-terminal, which is alpha and gamma, on the left side must be the same as the one on the right side. Okay, so in the right side you also have alpha and gamma. Okay, but for the beta, it can be anything from terminal or non-terminal. But for type 1, the alpha and gamma must be the same on the left and on the right. That is the second rule. The first rule is they must have non-terminal symbol on the left side. Okay. So for example, here you have a S, A, B, and then you have C, A, B. So we can see here A, B is the same here. Okay. So then you see a C. Okay. So we can say that A, B could be a gamma. Okay. C can be beta. Okay. S would be the non-terminal. So what about the alpha? In this case, alpha is empty string, which is epsilon. Yeah, epsilon. So means that here they fulfill the restriction saying that the alpha is the same, which is epsilon. The gamma also the same, which is AB. Okay. Then the beta they have is C, which is a terminal symbol, and also they have a non-terminal symbol S on the left side. So this is a type 1 grammar. Now we look into a context-free. A context-free is a type 2. A context-free grammar is one in which each rule must be of the form A goes to alpha, where A represents a single non-terminal and alpha is any string of terminal and non-terminal. So the type 2 is quite easy to see because you need to see that the left part of the grammar is a single non-terminal. Nothing else. Must be single non-terminal, nothing else. But on the right side, you can have any string of terminals and non-terminals. So that is type 2, context-free. Okay, then the last one is a type 3, which is right linear, or sometimes they call it a regular. Okay, a right linear grammar is one in which each rule is of the form of A goes to AB or A goes to A. So what you can see here, as I said to you, in order to be a type 3, it must be in type 2. So you see that in type 2 say that, the left hand side must be only single non-terminal. That's it. So in type 3 also you will have that as well, single non-terminal. Now it restricts it further. On the right side of the grammar, there can only contain two conditions. Yeah? Either single terminal or terminal followed by non-terminal. Single terminal followed by single non-terminal. That's it. That is the restriction for the third type 3. Yeah, type 3. So type 3 you only need to see that it is a type 2, then the right hand side must be only terminal or a single terminal followed by non-terminal. If it is vice versa, means that you have non-terminal followed by terminal, it is not type 3. So it automatically go to type 2. It must be terminal followed by non-terminal, not the other way around. Okay. So the third one normally is used to define a lexical items such as identifier, constants, and keyword because it's quite strict. Yeah. And a context free is normally used in the grammar. Yeah, the grammar that is well known is a context free. Okay, now this is exercise. Some of the examples of the questions that asking about a type of grammar. Classify each of the following grammar rules according to Chomsky classifications of grammars. In each of case, give the largest example, most restricted classification type that applies. So you have type 1, 2, and 3 or 0. Okay. Okay. So the first one, ASB goes to AACBB, that is type 1. This is context sensitive. Okay. And then how do you know it's a context sensitive? The first is the left hand side must have a non-terminal, which is S, and the alpha and gamma must be the same. In this case, on the left hand side, the gamma is A. You have also A here. You have B. You also have B on the gamma's right hand side. So means that the one in the middle here actually is the beta. Okay, that is type 1. Second one is a type 3 because you have a one single non-terminal and terminal followed by non-terminal. The third one is a type 0, is unrestricted. It means that it's not type 3, it's not type 2, and it's not type 1 as well. Okay. Number 4 is the type 2, is a context free. So S goes to, I think the number 3 they have error here, yeah, corrections is actually the same. It's supposed to be in types 2. Okay, so the third one is incorrect. Okay, so for number 4 is a type 2. We have a single non-terminal on the left hand side and any number of terminal on and non-terminal on the right hand side. Fifth is a type 1, is a context sensitive. We have A as a non-terminal, and we have a gamma B, and we have an empty string for alpha and beta. Okay. Number 6 is type 0, is unrestricted. We have AB on the left hand side and BA on the right hand side. So that is unrestricted. Okay, so that is the types of grammar. Okay, so for the next lecture, we will look into further detail on a context-free grammar because this is the one that actually we will look into deeper later on. Okay, thank you very much.